Okay, I'm gonna leave Yeti X on because also last time I lost auto recording. But this is me on C Sharp Survival Guide rotations. So I'm on rotations now. You got to do these four to work with the rotations. After that, variables, if statements, switch ups, switch up. Let's get started. Let's watch and then let's do it.
In this video, we're going to talk about quaternions and ordinals. What are quaternions? Well, for starters, quaternions are just how Unity handles rotations. It's a very effective way for rotations to occur in game development. It's nothing to be afraid of, just know it's how Unity handles rotations. Now let's talk about something we all have maybe heard of called Euler angles. Euler angles are also nothing to be afraid of. You'll see here that in the Euler angle camera, we have a rotation value of 0 along the x, 0 along the y, and 0 degrees along the z-axis. These degrees along the specific axis is the Euler angle. So for example, if I set this at 30 degrees on the x rotation, that is 30 degrees along the x-axis. That is the Euler angle of this axis. If I set this at 50 degrees, the y-axis or the Euler angle along the y-axis is 50 degrees. It's just the amount of degrees that we're rotating along the specific axis. That's the Euler angle. What's happening underneath the hood is that Unity is using quaternions to handle the rotation, and they're representing it to us in a Euler angle fashion because it's just more real. If you're familiar with quaternions and mathematics behind it, quaternions have an x, y, z, and w rotation. But because we're not really comfortable or familiar with the w rotation, you can convert it to Euler angles to be more real. So we have here 30, 50, and 0 degrees. The individual rotation along the x-axis is the Euler angle. 50 degrees is the Euler angle along the y-axis. That's the same rotation. So nothing to be afraid of when it comes to Euler angles and rotations or quaternions. Now, with quaternions, it's recommended that you always handle rotations through quaternions. You should never modify rotations using the Euler angles. And the reason for that is something called gimbal lock. Gimbal lock is the loss of 1 degree of freedom with three-dimensional free gimbal magnetism. That means that there are occasions where your y Euler angle and your z Euler angle may align and it will break the rotation. So when we gimbal lock, we use quaternions, and then Unity will represent that quaternion as an Euler angle too, so that you can make sense of it. So again, nothing to be too concerned about, just know that Unity handles rotations using what's called quaternions, and they're very easy and effective to use. I'll see you in the next video. We're taking a look at using what's called quaternion.identity.
Quaternion identity. I'm pretty sure that's when you just say it is the rotation that it is. I'm pretty sure, but we'll see. So pretty much what happens is within code, Unity represents the quaternions as Euler angles, which is the UE, which is the EU, LER. So like the Euler, like Euler angles, and it represents it to you like that. But what you're actually working with is quaternions, and that's what you're changing and putting in things. So whenever you do quaternion dot Euler with Euler, you're telling it what the Euler, what angles is going the Euler angle would be, but it's actually you're doing is being quaternion, but it's going to be represented. So what is it going to be represented as Euler angles? But you're not actually doing Euler angles. It's going to convert it to Euler angles, something like that.
In this video, we're going to take a look at working with quaternion identity and what that means and what it is, as well as how we can specify rotation using the quaternion Euler definition. So let's check this out. I have a simple program here with a spawn cube. I specify the object on the spawn, and then here I have an update. When I hit the space cube, I'm going to instantiate an object. So if you're familiar with instantiate, how we create and spawn objects. So here I'm going to instantiate the cube prefab. I'm going to instantiate it at the center position of the game at 0, 0, so vector 0 at 0. And then typically what you'll see here is when we instantiate an object, oftentimes we'll type quaternion.identity. And what this means is no rotation. I'm basically just going to set the Euler, the x, y, and z rotation values to 0. And if we save this and actually run the application, you'll see here that when we hit the space cube, we're going to spawn in a cube, and that cube is going to have a rotation value of 0, 0, 0. What if I want this cube to have, let's say, a y rotation of 35 degrees? Well, in order to do that, I would have to specify the actual rotation using the quaternion. So if I actually say vector 0 and a comma, you'll see here that if we look at the override for 4,
That is absolutely a lie. I always thought that had to do with. Well, I'm gonna check right now because I do not believe that that's true. I think he actually got that wrong. I'm not playing. I actually believe that that's wrong. So okay, so let's say you have you have a cylinder, right? Now, okay, so for scenes, we can still keep it within step one because we can keep it within that. Okay, let me take the cylinder and then let me rotate it by. So it's 45 along the X, right? 45 along the X. Now let's take the cylinder and make it that, a prefab. Now let me delete it, okay? Yeah, because I definitely want to see how does this thing get brought in, right? So you want serialized field, prefab. So I'm pretty sure it's just game object still. So game object, silly, that's it. So that we're gonna do instantiate. Then you want to instantiate the silly. Then you want this transform to be vector 3.0. Now, with this right here, I think personally, I'm just saying how I think it would be. I think it's going to still be rotated. It's not going to be 0. I think it's still going to be rotated. That's why I think he's wrong at. And you put that there, and as it instantiates it at the 0 point, it's going to be rotated still. Jesus, it's not rotated. Okay, I was wrong. Okay. I always thought that meant like leave it exactly the way it is. I always thought that. Let me try. Oh, I keep on forgetting. No, I could just do. You have this. You have it for transform. You switch to scripting, and then I want to go to the quaternions. I want to go there. Okay. These represent rotations. Also, if you're just using your local rotation, you just do transform dot local rotation as the rotation. So it's like this is your local rotation, and you transform dot rotation to do new rotation. So if you want to use existing, you use that, and that's for new ones. Or this could be for new ones as well. You could do this equals new one. Angle, view, versus slope, identity. So what is this? Zero rotation. Okay. Okay. I mean, I guess so. I didn't think it means that. So if I want the one I got, I guess you just do transform dot local rotation. I guess that's it. And I guess from there it'll go, well, what's the local rotation of it? And it'll still be rotated. Because that's the local rotation. So that's what I think it would be. What? Why is it zero? Wait, did I ever? Okay, it's rotated as a prefab is rotated. So it's rotated. So wait, why is it doing this? I don't understand. What if I leave it blank? Well, I guess you gotta put something in. I don't think there's any way to keep the current rotation of the actual object. I know that there must be a way, but I feel like I'm lost. Oh, that's why that's gotten rid of. Okay, so transform dot rotation. So would that be it? This is insane. I gotta go ask. Hold up. Okay, I'm so retarded. The reason your script isn't working as expected is because transform dot rotation used the rotation of the object running the script, not the prefab save location. But just please ignore anything I ever say. I am so brain dead. Obviously, it's not going to use. Obviously, is using the rotation of the script. You have to go transform dot rotation. Oh my god, I am so retarded. You have to use its rotation, not your own, dumbass. I was using transform as if I was just Jesus Christ. And I'm pretty sure the other one will work as well now. Transform dot local rotation. I'm pretty sure that would also work as the exact same thing since there's also a local rotation. Jesus Christ. What other things did I put in there I was trying? Wait. Oh, so there's no paternity on the actual game object. Okay, so paternity dot identity is just okay. Okay, so that's a part of the Unity engine. So I guess this isn't a part of the Unity engine. Okay, so it's really a part of a game object. Okay. Well, I mean, the paternity identity isn't being called from the game object. That's the point. It's not being called like from a component. It's more so just like a function or something like that. I guess not a function, but like I don't know. But check. It's a static property, specifically a read-only variable. Importantly, you don't use readable properties because you aren't running a task, but you're reading a stored value. Okay, so it's just a constant set to 000. Okay, so it's just a vector 3. Okay. No, it's not a vector, it's a quaternion. Okay, I get it. It's a quaternion. Okay. Never mind. I get what's happening. Okay. Okay.
If passing for an object, the position is on the object, and then quaternion rotation. We can define the rotation using quaternion. And if I pivot quaternion dot, I have a choice of identity, which again means no rotation, or I can actually specify an Euler. And if we look at the definition for Euler, it's really a return rotation that rotates z degrees around the z-axis, x degrees on the x-axis, and y degrees around the y-axis. That's what an Euler angle is. It's the specific rotation along that axis. So 35 degrees along the y-axis is going to be the Euler angle on the y-axis. So to use this, you'll see here that I can just type dot Euler, and I open a parenthesis, and I can pass in my x, y, and z rotations. So here I'm going to say 0 on the x, let's do 35 degrees on the y, and then let's do 0 on the z. We can save this, hop into Unity, and now when I hit the space key, you should have an Euler angle of 35 degrees along the y-axis. And you see that our Q is 0 on the x, 35 degrees along the y-axis, and z is 0.
Okay. One of the things I wonder is what's the difference between all the other ones? I'm going to do this one anyway, but what's the difference between all the other ones? You'll say 0, and you'll say quaternion dot Euler, and you'll say 20 on that, and you'll say 20 on that, and then 20 on that. And it'll still have silly going silly. Changing up his rotation from what it may be. That made no sense. Why did it not change? This is definitely not 20 every single way. Oh wait, it is. What? Maybe it's because how I'm looking at it. How about this? I'll do 90 across that, and do 0, and do 0. I'll do it. It'll look better. 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 There you go. But now I need to see what's the difference between quaternion.Euler, quaternion. The other ones, and stuff like that, because I have no clue what that is. So quaternion.Euler is converts an input Euler angle rotation specified as 3 floats to a quaternion. Okay. Now, Euler angle, what's that? Wait, so this is a static method, okay? This is a static method. Now, this is a property. Returns or sets the Euler angle representation of the rotation in degrees. And this is a static property. It means it only belongs to the class. It's a property that belongs to the class. Now this is a method that only belongs to the class. Okay, what I need to see is what are Euler.angle versus Euler angle returns the angle in degrees between two rotations A and B. The resulting angle from 0 to 80 returns the angle in degrees between two rotations. So I'll give it two rotations. Wait, let me try to use this. This is stupid. Let me try to do something with it. This is stupid. So I'll take, so let's just say between 0 and 45 is 45. So it'd be 45, but it's already 45. So how about this? What if I say, well then, yeah, if that's true, then after that it'll be, let's just say 0 and 90, because then it'll be 90 if it works out that way. Okay, I'm gonna have to do something else. But I'm gonna try to see. I wanna know what's the difference between quaternion Euler and Euler angle. One is a tool to create a rotation, and the other is a way to read or modify an existing one. What? A property of an existing object like transform quaternion that represents rotation in degrees. You use it to read the current degrees of an object or to modify them by adding, subtracting. Angles plus equals new vector 3. Use this when you need to know the current degrees of an object or want to tweak individual axes. Adding 5 degrees to the y-axis everything. Never use it to increment rotations over many frames. Would I ever need to use? Okay, let me try to use it then. Debug.log. Obsolete. Use quaternion Euler instead. Bro, if they obsolete, like, I'm cool on that. I don't really need to. I don't need to understand it really. I'll try it, but wait, but like, isn't it like on it? Yeah, I don't need to use it. It just literally don't make any sense that I don't need to figure it out. But I want to see an example of this being used so I can see it. Well, I mean, you could just click on it. I mean, that's like simpler. Okay, returns the angle in degrees between two rotations. Okay, so between two rotations. Oh, so I would need a rotation. Okay. So it should be 333. It should be 333 down here. Wait, it returns the difference between the two. So shouldn't it be like 9 or something? It's returning the difference between this Euler and this Euler. So shouldn't it be like 9? The method is just the shortest total rotation between two dimensions, whereas your expected 9 is just a simple sum of the three simple axes. What? 3D version of distance. Okay? You are thinking of the Manhattan distance. Okay, so it works like a distance. So what it's saying is that between the 3 and the 0, the direction is pretty much turning the magnitudes. I want to see that. Because he said it's 5. So I want to see if it's really 5. I want to see, like, can I see, like, a 5 something in there? So that says 5.1. Okay, so this should be like a 5.1. Let me try to see. Make it flat. Let me do it that way. Okay. So it should be 5.1. 1, 2, 3. Okay. Maybe it's just because it's in that angle. Also 3. Also 3. Bro, I don't know how do you check to see, like, how do you know what a magnitude is? Like, how do you measure a magnitude? I just don't get it. How is this 5? 5 what? Okay, never mind. I'm done. Okay, so that was quaternion dot identity. That was that.
30 degrees along the y-axis. And you'll see that our cube is 0 along the x. We can save this, pop to unity, and now when I hit space key, we should have an order angle of 35 degrees along the y-axis. And you'll see that our cube is 0 along the x, 35 degrees along the y-axis, and z is 0.
You just use quaternion dot Euler. That's the main part of it. But
In this video, we're going to take a look at something called quaternion.location. In 3 games, it's super useful to use this because what it allows us to do is we can specify what.
I can never figure out the quaternion dot angle. I cannot figure that out. No matter what I did, I was not figuring that out. That was not happening. So that's a wash. I am not figuring out quaternion dot angle. That cannot be done. It's impossible. It has something to do with a magnitude between two vectors, which is like getting like the shortest possible path between two vectors. So pretty much, you could travel like 5 meters. The best way I would say it is, it's the shortest possible path between two vectors. So I would think if you did it, let me check, see if I'm correct. I think 1 is the shortest path between 1 and 1. But I think it only gets more complex. So for example, let's say I do something like the shortest path between, let's say, 1 here. Let's do 0 there, 0 there. Let's do 1 here, and let's do 0 here. So this should be 1. The shortest possible path between those two should be 1. And if that is the case, no, I'll change the wrong one. So stupid. But 0, no fault. 0, 0, 0. First of all, let me check something with this. I want to see if it's 0 even with that. So at least the shortest possible path, I know is 0. At least I know that's what I'm measuring. Okay, 0. Okay. Now let's just add 1 to here. Now let's just see what changes specifically. So now, is it just 1? Because if I add 2, then it should just be 2 as long as it's in one direction. Well, it still is 1, but then it's like a little bit more. So it became weird a little bit, but let's just put 2. So now it should still be 2, but still with like 0.137. It should still be like 2 though, because the shortest possible path is still that. Still should be the shortest possible path. Okay, 2. Okay. Now if I put 49, 35, it should still be 35. Just to make sure that we're going along the shortest possible path, which means it should still be 35 still, because that's the shortest possible path between two spaces directly. Okay. Now if I add 2 here, 3 here, now it should go crazy, because now it should be something completely different, because you now changed it up some because you also added on another vector. You added on the y. So now it's like, well, it's not crazy, but it's still 35 because it's pretty much trying to say, okay, I get it. But I guess it measures the shortest possible path. Returns the angle in degrees between two rotations. The resulting angle ranges from 0 to that. Returns the angle in degrees. Returns the angle in degrees between two rotations. So if you have 0, 0, 0, which is no rotation, and you have a 35-degree rotated thing, it returns the 35 degrees rotated. But if you have it also rotated along the y, how would it even return that? I don't know. They said the shortest possible path, but it's returning rotations, not paths. So what? I don't know, man. Because this has nothing to do with paths. Okay, so I'll put that this has nothing to do with distance. Isn't it about rotations? Meters of physical distance is entirely about rotational distance or rotational distance. Okay, I figured it out. I figured it out. Okay, it's literally just the Pythagorean theorem. That's literally what it is. It's the Pythagorean theorem. It's I say it like the Pythagorean theorem. It say exactly. It is exactly like the Pythagorean theorem, just in 3D, but technically 4D space. In 2D, the Pythagorean theorem is a squared plus b squared equals c squared. It tells you the shortest distance between 2 points. In 3D rotation, you are essentially doing the same thing to find the shortest tilt between two orientations. The comparison, if you want to know the total tilt of an object rotated at 3 degrees on X, 3 degrees on Y, 3 degrees on that, the math is, so it's literally telling you the distance between 3 different locations in the shortest path. Not locations, but 3 rotations. And the shortest rotation between them, I have no clue. But all I know is the way to get the correct answer is by using the Pythagorean theorem. So what you do is you do 3 times 3 times 3. 3 times 3 equals 9, 20. Then you add it up 27. And then from the 27, since you use 3, you then get the square of 27, which is 5.1. So 5.19 times 5.19 equals that. So that's all you do. So for example, I could do it again, and it's very easy to predict. Let's say I wanted to do let's bring back this. So if I want to do this, you do 0, 0, 0, you do, so let's say you want to do 20 by 2 by, let's say 7. So that means you're going to do 20 times 20, which is 200. So that means you're going to have 200 by 4 by 49, right? Now, what you want to do is you want to add, because that's the square of all of these. So after that, you want to add all of these up, right? Wait, is it 200? Could be like 2. Shit, I'm sorry. Yeah, I just forgot what it is. But yeah, it is 200. God damn, my brain is fried. Okay, so the square of that is that. Okay, so it's 253 altogether. 253. So now what you want to see is that's it added up. So what's the square of this? So what's 10? So 10 times 10, 100. 20 times 20, 200. So maybe 25. So maybe something around 25 times 25 is so 20. No, that's damn sure not it. That's 300 or something. So it's maybe 200 and not 210. No, it's 205, right? No, 207 because 7 squared is 49. Yeah, so it's 2. So it's 207 point whatever. That's going to be it. 207 point whatever. So the answer is 207 point whatever. Watch this. Because 7 squared is 49, so you get 243. What? Let me just try this real quick. What? It's 400. God damn, I'm an idiot. Wait, why would I expect to see 200? What was I even saying? I meant to say 27. That's what I meant to say. But even then, that's still 700 or something. So why would I? What was I even saying? Bro, I understood it a little bit. That's it. I don't know, man. Yeah, the reason why it's like that is because this is 400 with 4, and then with 49, and then it's 453. So 21.15. It should be 453. It's around 453. If you add the rest up, it'd be 453. That's it. But you still know how to do it. My brain is just completely cooked. I'm brain dead completely. So don't worry about that. But you pretty much understand what kind of thing is happening. It's a Pythagorean theorem kind of thing to get like a magnitude between two different. I say locations because it's like a Pythagorean theorem. So I say locations. I don't know about all that rotation stuff. So I say between locations, even though it has to do with rotation. Oh yeah, I had to look up the Pythagorean theorem video, figure out how to do it again.
Object to target or look at another object. Here's a strict API for returning to the community, and the function that we're going to its implementation. We include create rotation to specify forward and upward direction. And what this allows us to do here is we're basically going to calculate the direction for our character to face, and then using the returning on rotation, we can pass in, hey, go ahead and point in this direction. So the key here, though, is being able to calculate the direction of the point. So here I have the key method that I downloaded from GameBase file base, and on this asset here, we have upper body, and what I want to do here is I want to have this character rotate here, though, is being able to calculate the direction of the character to face, and then using the returning on rotation, we can pass in, hey, go ahead and point in this direction. So the key here, though, is being able to calculate the direction of the point. So here I have the key method that I downloaded from GameBase file base, and on this asset here, we have upper body, and what I want to do here is I want to have this character rotate and aim towards the sphere. So in order to do that, you need to work with returning and handle that rotation. So here I'm going to create a new C# script, and let's call this aim. The upper body aim object, I'm going to attach this to it. So here I just want to move up the right here. I'm going to attach the aim script to it. Open this in Visual Studio, and here's what we need to do. The first thing we
The
need to
link
do
rotation is just saying where is the Z going to face. That's the first thing. You're pretty much putting in the direction is going to face. That's what it wants to know. What's the direction is going to face. And to get a direction, you just take wherever you're looking at and then subtract it from where you're starting from. So if you're at 0, and you want to look at 3, you just go, well, I'm looking towards 3, so subtract 3 by 0, and then you look at 3. That's it. If you do it the other way and subtract 0 by 3, then you'll look at negative 3, negative 3, which means you'll look to the opposite way. So you have to subtract where you're looking from where you're at. That's the way to get a direction, to know where to look at.
is who is this script where we are.
That's the way to get any direction at all.
So what we need to do is figure out how to calculate the direction of face. And it comes down to what is the formula for calculating direction. And it's quite simple. Direction equals the destination minus the source.
Yeah.
And this is going to return a vector 3, which is going to specify the direction to aim at. So in pseudocode, we have direction equals destination minus source. What is the destination? The destination is the target enemy or the sphere. The source is who it's coming from. The source is us, the mech. So the destination is that sphere. And we're going to take the sphere and a reference to it. So I'm going to create a variable to transform to store the reference to that sphere. Using a single sphere attribute, we can assign it an index vector. If we hop into enable that compile, our aim script is now going to have a target that is going to the sphere. So we're just going to hop in here, drag a sphere, and then let's go on formula for direction. Here I'm going to say vector 3, direction, and we call this direction to face if we want, equals the destination. The destination is the sphere. So sphere position minus the source, outward position. So I'm going to say transform that position. Now that we've calculated the direction of face, we can take our current rotation of our map, and we can say, hey, face this direction or look this direction. So to do that, we have to access our current rotation. So we access our current rotation, and we assign it to the Quaternion look rotation method. So we say transform that rotation, and if I calculate this here, so we're putting Quaternion, it returns Quaternion, and we say Quaternion.look rotation. And when I open my parentheses, it says vector 3 forward direction. All that. Forward direction is where I want to look. I'm going to pass in the direction face. If we save this and hop back into Unity, you'll see here that when you start the application, when you click the sphere, and no matter where the sphere moves, it is rotating towards the sphere. And that's how the rotation works. So now it always has a lockout target to the sphere rotation. Now let's further understand this. If I open up the script here and I want to visually see how does the direction calculate, what is that direction vector look like, we can do something called a debug.drawArray. And what that code allows us to do is I can draw array from a vector 3 start position to a vector 3 end position. So here I'm going to start the array at transform that position, and I'm going to cast it towards the direction to face. And I'm going to specify the color of say green. This is going to allow us to actually see the calculation of direction happen in real time through the scene view. So once you compile here, in the scene view, you're going to see this green laser shield from our mech. And here you can see here that it's calculating the direction. And as we move it, it's calculating what the laser sight. So it knows exactly calculation of direction green. This is going to allow us to actually see the calculation of the green. This is going to allow us to actually see the calculation of direction happen in real time through the scene view. So once you compile here, in the scene view, you're going to see this green laser shield from our mech. And here you can see here that it's calculating the direction. And as we move it, it's calculating what the laser sight. So it knows exactly where the target is. And that's what the direction formula is doing.
The reason why you don't want to just put it in the sphere, because the sphere's place is in the direction to look at. It still wouldn't tell you where to look at by putting it in the sphere global position. It wouldn't tell you exactly where to look at because of where you're at. Because once again, you would have to take into account where you're at. So that's why you have to use yours, then subtract it, then subtract where you want to look from yours, so you can get where exactly you want to look. Because the sphere's place, wherever the sphere is at, that location is not a specific direction, like in the actual thing like that. You're not using like global things of like look at 0. It's not that way. You're not saying do that. You're saying if you use 0 direction, then it's going to say, oh, I'm looking, or like let's say you use 010, it's going to say, let's say you use 001, it's going to say I'm looking forward. That's what it's going to say. If you do 010, it's going to say I'm looking up. That's it. That kind of stuff. I understand this one though, but just mark this one as complete. It's really going to be really easy to do. You just do man, which one am I even on? What thing am I on right now? Okay. So you want to do Transform. What? Look rotation. So where do you want the forward to be? You could do vector 3 dot forward, vector 3 dot right, and then you could say times 45. Now you're gonna look 45 degrees to the right. I mean, you literally could just do something like that as well. Just saying. Yeah, you're gonna look 45 degrees to the right. I know it sounds stupid, but it would work. This works, by the way. You're gonna look 45 degrees to the right. See? 45 degrees. Oh no, you are looking to the right, dumbass. Because the right mean you're looking straight to the side. But that when you multiply that, you're already at 90. So you're just multiplying 90 by 40, right? Aren't you doing that? I don't know. Wait, what is this going to be? Oh, 90. Okay. And that's still 90? Or it's still 90? I guess because even if it's at 180, you're still looking to the right, so it doesn't matter. Oh, I get it. So it doesn't matter if you put in 360. So for example, new vector 3, and then if you're looking to the right, you do that. And then if you do 360, you do 0, it's still going to bring it back down to just 90 or whatever. Because even if you rotate around the Y, it's still going to say, this is 90. I don't give a F what you're doing. This is 90. It's 90 or negative 90. But yeah, it doesn't care about any of that. It's going to say it anyway. Okay. That's interesting. Uh, one of the ways you could do it is if you create a cylinder, and then if you want to say vector 3 new vector equals silly dot transform dot position minus transform dot rotation. No, transform dot position. That's it. Now you want to look at new direct. That's it. Oh, I gotta re-put in update facility. Oh, I don't. I think it's still there. Yeah. This rotation don't matter. Yes. No, I put it in for the. That's cool as fuck. That's really cool. I ain't gonna lie to you. That's cool. Alright, let's do slurp and then we get started with variables.
In this video, we're going to look at something called quaternion.slurp. Now, slurp is the equivalent of linear interpolation, but spherically. And what that means is that instead of just snapping into our target like it is currently, so if we run this, right now it basically walked on and just snapped into it. If we use slurp with loop rotation, it will allow us to basically control going from point A to point B. So basically, it would be able to smoothly spherically interpolate between the current rotation to the target rotation. So instead of being a snapping motion, we would actually be able to see it spherically and smoothly go towards the target rotation. So to do this, it's pretty simple. We still have to know the thing we're doing here. If we calculate the direction of the base is our target, I need to know what is my target rotation going to be. So that's going to be stored in this direction. The thing we're not going to do though is we're not just going to snap our rotation to look at the target. We want to spherically interpolate between our current rotation and the target rotation. So to do that, we're going to store this look rotation, which is our target here, in a quaternion variable. So we're going to say quaternion, and let's call this target rotation. The target rotation equals the look rotation. So that's telling us, hey, that's where we're going to go. What we're going to do now is we're going to take our current rotation, which is transform that rotation, and we're going to set it equal to quaternion.slurp. And when we open a parenthesis, we have two parameters here. We have quaternion A, which is our from rotation, and quaternion B, which is our target rotation. And then float T is the time it takes to complete the rotation. So here, quaternion.slurp, our from rotation is our current rotation. So I'm going to say I want the map to go from the current rotation, transform that rotation, to the target rotation. And the target rotation is equal to the look rotation, and the look rotation is the direction of the face. And here is the passage time, basically the speed of how quickly you rotate. Times the time at delta. If you want it to be say 2 inches per rotation, you multiply this by 2. So we do it, time delta. Let's see this. Add to unit. Let's test this out. We should now see you guys use transition from current rotation towards its predict. And so here we know the watch it go to. And as it goes up, it's up to snap it and 7 choose watch it glide and lucky you snap. I think I could do it without. So you make the turn in, then you I forgot it. I have to see it once. Okay, so what I'm thinking is, I know he stored this into a quaternion. So he made a quaternion, called it target direction, and then he stored this quaternion into that quaternion. Okay, then he transform that rotation equals quaternion dot slurp, and then with that one he stored this one that was here. So that's what I'm thinking he did. I don't know, I can't really remember, but what he did is he made a quaternion target direction, and then he made it equal this right here. That's it. And then he did transform that rotation equals quaternion dot slurp. And then it's transform dot rotation. And then it's target direction. And then it's time dot delta time. Yeah. But now, no matter how it changes, it does it in a very smooth way. It's not direct and like very snappy to just go along. See? It's kind of cool. That's real cool. I like that. The real cool part about it is when you have AI characters, you can make them look around. You can make them like. Why don't all games have AI characters that can look around like this at all interesting things around them all the time? They do it all the time. Wouldn't it be like so cool when you see characters looking around all the time at things, looking down, looking back at you, looking back at the person they're talking to? Where the act of constant looking as people act is like one of the most insane things. People constantly looking at different things. It's the one of the main things I think people look alive is the constant looking. Okay, all right, I pushed the continue thing. So that was leveling up. You have leveled up your skill. So I leveled up. Okay, so after this, I'm going to variables. This will be it next. So I'm done.